Hey guys, it's Mrs. Diaz again. We're going to look at some more practice from Unit 4A. So this is under Unit 4A. I want to remind you guys about inverses. So if you ever see that little -1 sine inverse, or cosine inverse, or tangent inverse, we're going to talk about inverses a little bit later, but these are when you have restricted domains, which means you can only look at certain quadrants, okay? Now, in these examples here, we do not have inverse, so we do not have to restrict the domain. Only restrict the domain when you have the inverse sign, which is that -1. So in these examples, we are going to read the instructions, solve the trigonometric equations using the unit circle. Answers should be between 0 and 2 pi. And look at that, we can equal 0, we can equal 2 pi, so we are in radians. Each question may have multiple answers. So this is when I said, we are not restricting the domain because we do not have that inverse symbol. Okay, so to do this problem, sine theta equals √2/2, we're basically thinking backwards. Where is sine, which is the y-coordinate, √2/2? Well, I'm going to pull up the unit circle, and the y-coordinate is √2/2 here at pi/4, but also right here at √2/2 at 3 pi/4. So the answer for this first one is pi/4 and 3 pi/4. Okay? Now, if we were talking about the inverse, we would have a restricted domain, but we are not talking about the inverse, not yet anyways. Let's try number 3. Tangent theta is equal to -1. So remember, tangent is our y/x. We are trying to figure out where on the unit circle is y/x -1. Well, that has to be at one of the pi/4s, which I would say here 3 pi/4. Because if you remember correctly, the coordinate is -√2/2, comma positive √2/2. When you do y divided by x, you get -1. So there's 3 pi/4. Also, on the other side, which is in the fourth quadrant, that coordinate is 7 pi/4, which is positive √2/2, comma negative √2/2. When you do y divided by x, you get -1. So 7 pi/4. The ones that do not make sense would be in the first and the third quadrant because they will be +1, not -1. All right, let's continue on. Let's try something like this one. Secant theta is 2√3/3. Remember, secant is 1/cosine. So what I do here is I want to take the reciprocal of cosine to make it cosine/1. Well, to do that, I had to flip the fraction. So I'm going to do the same thing here. I'm going to flip the fraction to make it 3/2√3. Remember, you can't have a radical in the denominator, so you're going to multiply top and bottom by that √3/3. That's going to turn into 3√3/2 times, these turn into a 3, so 6. The 3 6's will simplify to √3/2. So we are thinking about where is cosine √3/2 on the unit circle. √3/2, that's going to be the x-coordinate, which is pi/6, and also √3/2, comma -1/2, which is 11 pi/6. So the answer here was pi/6 and 11 pi/6. And we're thinking about the x-coordinates because cosine is x, which is the reciprocal of secant. Let's keep going. I'm going to do this one right here, tangent. Tangent of theta equals √3. So tangent is y/x. We basically want to look at the coordinate where it is going to be a 1/2, comma √3/2. Because when you do the y/x, you're going to get √3/2 divided by 1/2. And then we multiply by the reciprocal, so we multiply by 2/1. Multiply by 2/1. and that's going to get us root 3 over 1, which is root 3. So where is the coordinate, where does the coordinate 1/2 root 3 over 2 lie? Well, that's going to be here at pi over 3. That's the 1/2 root 3 over 2. And also in the third quadrant, which is 4 pi over 3. I can't really read that. 4 pi over 3. Because remember, they're both negative in the third quadrant, and a negative divided by a negative is positive. So the answer here is pi over 3 and 4 pi over 3. There it is. Let's look at what else is on this page. It's a lot of similar problems. Let's try one that's undefined, like secant theta is undefined. Well, remember secant is 1 over cosine. I keep getting secant, I should try a cosecant. But secant is 1 over cosine, so it's the 1 over x. So we're thinking about where is x going to equal 0, because when you do 1 divided by 0, that's where you get undefined. So on the unit circle, cosine, this coordinate here is 1 comma 0, so that's not our x coordinate of 0. But this coordinate is 0 comma 1, and this one is 0 comma negative 1. So this is where our cosine is 0, and that's at pi over 2 and 3 pi over 2. So all the answers here, we're looking at pi over 2 and 3 pi over 2. Those are our two answers. As you guys will notice, a lot of these have two answers. And that's normal, but remember, because we're not talking about inverses, we can have multiple answers. I'm going to go ahead and switch gears. We're going to take a look at the next homework, so I'm going to cancel that one. The next homework is trig identities. It's been a while, you guys, so I really want y'all to touch up on your trig identities. I'm going to do just a few here. It says simplify each of the following to an expression involving a single trig function with no fractions. So no fractions. Here we go. We got cosecant of t times tangent of t. T is our variable, so it could be theta, it could be x, it's just a variable. But remember, cosecant is 1 over sine, and tangent is sine over cosine. What you'll notice is the signs cancel. We're left with 1 over cosine, and 1 over cosine is secant. So our answer here is secant. Okay, now remember, they did say no fractions, so I couldn't leave it as 1 over cosine. I had to simplify that to secant. Let's try number 3. Secant is 1 over cosine divided by cosecant, which is 1 over sine. Now we can't leave it like this. We are dividing by a fraction, so let's multiply by the reciprocal. That's going to be sine of t over 1. Sine of t over 1. That's how the denominator just goes away. We're left with 1 times sine, which is sine, divided by cosine times 1, which is cosine. And sine over cosine is tangent of t. Now, before we continue on, there were some identities that we had to memorize, and the most important ones, besides, of course, the reciprocals, are what we call the Pythagorean identities. The most important Pythagorean identity is cosine squared plus sine squared equals 1. That's the most important one. Cosine squared plus sine squared equals 1. Or you can rewrite it as sine squared plus cosine squared equals 1. The reason I talk about this one is because look at number 6. Number 6 has 1 minus sine squared. Well, if you look at the Pythagorean, we can subtract sine squared on both sides. When you subtract sine squared, you're left with cosine squared equals 1 minus sine squared. So on this 1 minus sine squared, that's equivalent to cosine squared And then this is over sine squared. So cosine squared over sine squared, that's going to be cotangent squared. So the answer for number 6 is cotangent. I'm going to go ahead and skip down to the bottom to see what other examples I have here. It has been some time, you guys, so this is a good, hopefully, refresher in bringing back some of those memories. Let's look at number 7. We have sine squared plus cosine squared. That's an identity. That's 1 over cosine squared. Remember, 1 over cosine is secant. And it is squared because the cosine is squared, so it's secant squared. Okay. Number 10, I would say anytime you see these parentheses, your thoughts should go straight to foiling. So FOIL 1 times 1, that's 1. 1 times negative sine of A is negative sine of A, or more like alpha. Sine of alpha times 1 is positive sine of alpha. And sine alpha times negative sine of alpha is negative sine alpha squared, negative sine squared. Notice the inside pieces will cancel. You're left with 1 minus sine squared of alpha, and that was the identity from above, which is cosine squared alpha. There you have it. I'm going to go ahead and stop there. We're going to do a couple more videos, so keep practicing. Take a look at these old homeworks, and I'll be opening up Canvas quizzes so you can try those once again. All right, see you guys.